Dear followers, we are back with the last video of the third chapter. After learning about resistors and their notation, we are entering new waters, so I'll hand it over to Gergely.
Thank you, Bence. The capacitor, which is known from the revisioning chapter of basic physics, can be found in most circuits. In the component, an insulating layer, dielectric, can be found between the two conducting layers, electrodes. The capacitors have a symbol which refers to their physical structure, and they can be divided into two big groups. There are some whose polarity of the terminals is marked obviously. These are called polarized capacitors. When connecting these, you have to make sure that the positive terminal voltage is always bigger than the other terminal voltage. Otherwise, the capacitor can pop, explode, catch fire, which is dangerous. For example, if we charge a capacitor from a galvanic battery, the battery's positive terminal has to be connected to the positive terminal of the capacitor. This way, we also apologize to the managers of the crystal clear electronics summer camps, when last time I turned a tantalum capacitor into a liquid ball, with glowing pieces of it rolling around on a table under our glass dome, while demonstrating incorrect wiring. This is not a game. Everybody take the subject seriously. Please be careful. The notations for unipolar and polarized capacitors are also worth memorizing from the course material. Whether a capacitor is polarized or not depends mostly on the material it is made from. For example, the polarity is important at electrolytic and tantalum capacitors. However, the ceramic and foil capacitors are not polarized. It also changes whether the positive or negative terminal is marked on the component. For example, on the tantalum capacitor, the positive, while on the electrolytic capacitor, the negative terminal is marked. If there is no marking on the capacitor, then the polarity is irrelevant. Capacitor is marked with a letter C in a wiring diagram. The unit of capacity is farads with capital F. Of course, variable capacitors exist, but they're rarely used, so we won't go into their construction in this video, but instead, we'll move on to another simple but important type of component, switches and push buttons. A situation can occur when we want to make something detectable with a switch or a push button, or also when we have to turn off our circuit, but we do not want to do that by eliminating the power supply. In most circuits, a switch or button is used, which is marked in wiring diagrams. The symbols here can also be connected to the operation of the components. The essence of the switch is the fact that the electrical conduction can be interrupted. As the symbols show it quite well, by separating the conducting contacts from each other, which are in the switch, the route of the current can be interrupted. Opening and closing the ideal switch can also be interpreted as, at the moment of closing, its resistance is 0 and conduction is infinite. In turn, when it is opened, its conduction is 0 and its resistance is infinite. The push button is a little bit different. It only holds its opened or closed state while we are pushing it. There are switches which can be set into several states. The classical example of multi-state switches is the so-called lever switch, which can be seen on this figure. Bence, I know you brought one of the electronics you built earlier, which I can see contains quite a lot of pots and switches. What are these electronics and what exactly do they do?
This is a distortion pedal that can be used for electric guitars. In addition to the obvious connectors, there's a foot switch to turn the effect on and off, and 3 different potentiometers. The potentiometers for distortion and tone are linear, while the volume control is logarithmic to match the human ear.
It's time to say goodbye slowly. Though we could delve into more specifics about the component types introduced in the tutorial, it was enough to successfully overcome the next obstacles.
Először elegendő ennyit megértenetek ahhoz, hogy sikerrel vegyétek a következő akadályokat.
There are many other types of components that deserve further explanation, but we have left the detailed explanation for later video parts.
Részletes ismertetését a későbbi tananyag részekre hagytuk.
Before Bence presents our service announcements and we say goodbye, I'd like to ask Nikki, one of our backstage staffs, to put the last diagram from the curriculum section on the screen. Here, we'll list the component markings that will be presented and used in detail later in the lessons. If you cannot understand the wiring diagram later, you may want to scroll back to this diagram.
Thank you for listening to us in this episode, where you could learn the most important symbols and types for different resistors, capacitors and switches. Every important link can be found below the video. Follow our channel and Facebook page, where you can find out more about our latest news, and hope we see you in the next episode. Goodbye!
Bye bye!